Good morning, everybody. Welcome again. Maybe you heard the voice a little bit different, but hopefully you can bear with me, okay? So today I'm going to talk about a few important things. One is, we have the contract, right? We learned how to write one yesterday, but then we, in the lab session, we deploy it and we interact with it, but we didn't get into details, what's actually under the hood. So that's what we're going to cover today. So first, I want to introduce a few concepts here. If you look at the diagram, right? Let's see. Okay, this is more complete. So, we have a user. Maybe you are with a browser, a laptop, and then you have, usually you have some kind of front end. Either it's a mobile app or the browser, right? Web app. And then we have another role called a signer over there. So usually means it's a wallet, usually, but not always, okay? And then we have a concept called provider. Provider, as the name suggests, it just provides access to the blockchain network, okay? For example, it could be some, servers or some miners, usually, right? So simplest example, signer, you can think about it as a wallet that has a private key, and a provider is you can think about it as a miner, Bitcoin miner, okay? And then we have on the provider provides us access to the blockchain network, okay? So on the, you have again, as we talked about yesterday, you have a chain of blocks, and each block has transactions, okay? So transactions, as we talk about, when we deploy contract into using transactions, is going to be the output, okay? And each contract, smart contract, we look at yesterday, right? So it's a class, and then you can instantiate it. So it's each time you deploy, it's going to be a so-called contract instance. So when we have instance in an object-oriented way, that means we can use that instance to interact, to call it. Pretty much, it's like any other object-oriented instance. You create an instance out of a class, and then you can call its methods of that instance, okay? So this is a high-level view we have today, and then we are going to dive into the details. So for example, provider. So for us, out of the box, we have two types of provider. One is called a dummy. So most time you use it to do testing, okay? So today we are going to cover how do you deploy, how to call, but also we cover how do you test the contract, and also make sure if it fails, how do you debug one, okay? So dummy provider, most time you use it for testing. Anything else, you want to use the so-called default provider, okay? So you don't have to know, what's under the hood. You basically just use it, okay? Any questions so far about this diagram? So this is the, like a 30,000 feet overview of what we are going to do today. It's good? Okay. So let's dive in. Okay. Let's see how do we deploy a contract. Okay. So again, we are using the hello world. We deployed yesterday. So first, of course, again, you create an instance of it using new. You create a new instance, right? So here's the thing. Before you do deploy or testing anything, before you do anything else, you always call the compile first. Okay, you see the second await, hello world.compile. That's what you always do, okay, before anything else. So it essentially compiles, as the name suggests, right? Compile the TypeScript, sCrypt into the Bitcoin script we talked about yesterday. So before you do anything else, remember, just always do that first. And you don't have to care how it's done, but you just call it. And once you've done that, now we have an instance. So we can set up a signer, okay? So signer, as we talked about earlier, yeah, you can almost regard it as a wallet, okay? It's not always wallet, but yeah, you can regard it as a wallet, okay? So you can do a wallet. So basically, we also provide a simple signer called test wallet. It's, again, as the name suggests, mostly used for testing. So you can give it a private key, right? That's the signer. signing, you need the private key. And also you need to give it a provider. As I said before, most time you can just use the default provider. Unless you are only using for testing locally, then use the dummy one, right? Because here we're trying to deploy it, so we use the default provider, okay? So once we have the signer, how do you make sure, this one is connected? So we have an instance, right, on the blockchain, and then now we have a signer. So we need to kind of bind them, right? We need to, hey, this instance using this signer, okay? So the way you bind it is by call the connect, okay? You connect it. So once you have all this preparation down, now it's very simple. After this is all doing the preparation. You're not doing anything there's nothing actually happening, You're not broadcasting transaction, you're not reading from the blockchain, nothing happens. And then once you have all the work ready, then what's going to happen next is very simple. You just call it. So now you have the instance, you just call deploy. And that's it. Only one line, and now the magic happens. The contract is deployed to the network. That's it, just one line, nothing else, okay? And what is this 42 number? So basically, remember, each UTXO is a contract and lock up some satoshis, right? So that's the number of satoshis. I just put 42, but you can put whatever number you want. So this is actually the code we used to deploy yesterday. Yesterday is kind of like a black box. You just run it, you don't know what's under the hood. But now, hopefully with this, you get a better understanding what's under the hood, okay? Any questions so far? Let's deploy. Good. It's good. Okay. So after you deploy, what do you do next, usually? You want to, interact with it, right? Which we call calling. So you have a contract, let's say my contract, and you have some, public function, let's say foo. Right? You can, as we said earlier, you can deploy it. Once you deploy it, but then how do you call it? Okay. So this is how you connect, right? Earlier we had to talk about how to connect to a signer and then how you deploy it. So once you deploy it, it's very simple. How you call it, okay? You're just using this instance dot methods and using this, we can have one or more public methods, right? So you can just use the same name and then same parameters, arguments to call it. For example, you have foo, you have 2 arguments, and then you call instance.methods.foo, and then you pass all the arguments. And then there's a third option, there's an additional parameter called options. We are going to, for now you don't understand, but then when you customize, we are going to show you, why do we need these additional options. Simple enough. So basically when you call, you use methods property from the instance, and then you use the same name, and then you pass the same arguments to it. At the end, you may add an option, but for now, you can think of it's almost as if you are calling, some local instance on your local machine. So far, so good? Call? Okay. It's good? Okay. So that's one exception here. So basically what I just mentioned here, right? So if you have a public function method called foo and you take argument 1, 2 as arguments, you just use whatever regional type there is, right? But that's the only exception is where you need some signatures. Okay. For, if you still remember, we have all the people here, and we have him, her wearing the t-shirt. So if you have some methods that require the argument that is of signature type, you need, instead of just giving it the signature, you need actually use the so-called callback here. How many people heard about this concept, callback? JavaScript. So callback is is a function. Okay, so right. So for arguments, you have different types. Usually it's just data type, but it also can be a function. Okay, so it's also here, as I said earlier, if you remember the unlock method, it takes two arguments. First one is a signature. The second one is public key. Okay, so here, if we talk about last slide, you only need first give it a signature, and then you give it a public key. I mean, the second one is public key, no problem. Right? Again, you are calling the instance dot methods dot, the name of the public method you are calling. So you have public key, and then you have signature. But remember there, look at there, it's not just a signature, it's actually a callback function. Okay, so that's a notable exception. So we do that because, we want to simplify your life. You can compute the signature and pass it out, but most time it's complicated. So that's why we wrap it. So here, that's a magic happens. So remember last slide, right? So in addition to all the arguments that the public method has, you can also pass it as an optional, happen to call it options. So in this case, you want to tell the signer, okay, the signer is already connected to the instance. So here, pretty much you are telling the signer, which public key you want to sign, okay, the signature is getting from. So you can just tell, hey, I want to use this public key. So would you please sign with this, the private key corresponding to this public key, okay? So then the magic part is in the SIG response, in that callback, the SIG response will contain all the signatures that's generated by using the private key corresponding to this public key here. So once you have all the signature there, you can use a built-in function called findSig. You just find the signature out of its array here, find out all the signatures that corresponding to a given public key. Okay, so that's how the only exception you have is when you need a signature type, you use this syntax callback. You don't pass it as a native signature type. Okay, but that's the only exception. Everything else, you can just always use the original arguments. Okay, we need something outside of the smart contract module. So that's why when we talk about sCrypt, it's not only we call it a framework. We don't call it a smart contract language only because it also offers a lot of other tools that you can do things off chain. Right? Smart contract is supposed to run on chain, but you have a lot of stuff that's running off chain. Most notably, we call this we have a sub module called BSV. So what this does is, basically it give you all the primitives to build the BSV Bitcoin transactions. We showed you the structure of the transaction yesterday. You have inputs, outputs, you have log time. So you can all have all kinds of these fields. So you can, for example, here, we provide all these tools, the BSV module, sub module, so you can create, pair of keys. For example, you can create a random key, and then you can generate the public key from it. You can even generate address from it. And then we have all the different, for example, the hash function, right? SHA-256, SHA-1, wrapMD160. So you can all have all kinds of this built-in. We already provided, so you don't have to implement it. And also, the most important one, I think we are going to use later on is how do you build transactions? For example, here, I use a simple example. You can import the submodule from our library, and then you can say, hey, I want to create a transaction with this content. So for example, here, it says, hey, create a new transaction. From is pretty much from certain UTXO, right? So this input, from, I add an input, right? Input, have 4 fields you can think of. You have a TXID, you have basically reference the output, right? TXID, output index, and also what the script, what's the input script, and also what's the number Satoshi that I'm spending from. Okay, so that's pretty much give you all the information you need to construct the inputs. And then we also have an output. Okay, so this is like an address, and this is basically said, oh, this output goes to this address and has this many Satoshi. So this is a basic way for you to customize any type of transaction you want, because each property of the transaction you can customize using this syntax. Okay. I think in the lab session you're probably going to see some more familiar with this, and you are going to see a lot of actions to use this library, especially when you're constructing the testing and when you're trying to deploy transactions on chain. Okay. Any questions so far? This one? I think this, whenever you go to all kinds of blockchains, probably this is the first library you use, to build some simple transactions, so you can, and then connect to some so-called providers and broadcasting them, so you can watch them on chain in some kind of block explorer. Good. Okay. So previously we talked about how do you deploy and how to call in a single line of code, but that's not always true. Okay. So I kind of like I would say just skip the detail a little bit, because if you want using one line to deploy your code, that has some assumptions. So what are the assumptions? So it has some assumption about the format of a transaction. For example, when you deploy, right? So how many here still people are familiar with this term, P2PKH so far? How many people you got? So that's what the teacher says. So basically it's the Bitcoin address. Okay. So usually you have some UTXOs that basically think that's your own Bitcoin. So when you deploy, right, you have inputs, you have outputs. You have some inputs, right, because you are going to, put money into the contract output, and you may have some change as well. So you can have one or multiple so-called P2PKH inputs. Okay, they're going to pay for whatever goes into the contract, and also whatever change you have, plus you're going to pay for transaction fee. Okay, and if this is the format, I think this mostly when you deploy a contract, your transaction will look like this. Okay. If this is the case, you can just say instance.deploy. Okay. And then number of satoshis. And then we will handle everything, under the hood. Okay. So it's just one line. But if there's some special cases, your transaction when you want to deploy, it does not conform to this format. And then you have to use we just talked about the BSV module. You have to, provide your own transaction format. You have to build your own transaction, right? So for example, here, instead of only have one input and one output, I want to have another output, okay? For people, how many people have heard that you can, instead of only sending money or sending contract, you can also put upstream data on the Bitcoin network? How many you heard? Ordinals? Anybody? Anybody heard about ordinals? Okay, good. So NFT? Anybody heard of NFT? NFT? Oh, okay. So pretty much that's putting data, right? JPEGs or whatever, PayPay or Bored Apes, whatever it is. You put the data, right? The pictures, on the blockchain, right? So here is the same. You can using this. You can think about this, add another output. So this output usually is not spendable, so meaning it has 0 satoshis. And then you can dump whatever data you there, right? So here I just put hello world there. So this is another, you can think of a dummy output that has 0 satoshis. So you cannot spend it later. But then why do you want to do this? You want to put some data on the Bitcoin blockchain. It can be NFT. For here, I use hello world. It can be anything, right? Because it's just binary. Right? You can just dump it into the output for whatever reason. You want to timestamp it. You want to make a NFT. You want to have some fungible token, whatever it is. Because here, by default, right, we don't have such output here, right? So that's why you have to customize it. So how do you customize it? You override the class. You have a demo contract or whatever contract you have. And then if you don't want to use this format, So you have to override the function. You have to override this function called build deploy transaction there. Okay. So I assume you guys heard about if you do any kind of object-oriented programming, override. Anybody use override before? So you have a class. You have a method A in the base class, and then if you want to extend from base class A, but you don't want to use the method from the base class, then you can use the same. You can use the same name, but using the override keyword. Then basically means you are not using the function from the base class. You are like override. You are using the one that's in the child class. So yeah, you don't understand, that's fine. Basically, if you want to your deploy transaction doesn't look like this, you want to customize it, you just use this syntax and change the body here. Okay. Make sense so far? It's good? Okay. So we just talked about how to customize deploy transaction, right? Another way of course, is you can customize, as you probably have guessed. You can also customize a call transaction, okay? So call transaction by default, that's what it looks like. So you have the first input, right? Spending from the contract UTXO. The UTXO output that contains the contract you are trying to call, okay? So for example, hello world, right? We tried yesterday. The first one is your current contract. And then you may have a few optional so-called P2P gauge. You can think of that's a bitcoins. Use it to cover all the outputs, satoshis, but also you want to pay the fee. Okay. So you maybe have zero, you may have multiple. Okay. And then when you're coming out, if it's so-called stateless transaction, then it's destroyed, right? The contract is gone. So you can have optional, but we talked about yesterday, using script context, you can maintain state, right? So if you use stateful, you may have some more contract output, right? Because it contain the new state. You may have one, you may have more, okay? You may have zero if it's just stateless, okay? And then always you may have the change output, okay? So that's how when you call it, that's the default transaction format, okay? But again, you probably guessed, right? What if I want to, when I call it, I want to have a different transaction format. Then you can customize it. So here, the syntax is a little bit different because, instead of have one public method, right? Because we may have multiple, right? So you cannot just override one. So we call the syntax, you can say bind so-called transaction builder, and then the first parameter is a public method. When you want to customize the call, you give it the name. For example, here it's called unlock, and then you give it another, again, so-called callback function. This callback function just build your customized transaction. Okay, so using the BSV sub module we have earlier, you have in one input, one output. Then you have another change output. Okay, so we don't have, because here we can only have one P2P gauge output. For here, we already have one, but what if you have some change? Right? Changes you can think of as another P2P gauge output. So here in the default case, it's not covered, right? So what if you have two P2P gauge output with additional change? Then you have to, you can think of, you have to use this syntax to bind a public method with your own transaction builder. So in this case, you can customize, your call transaction. Maybe, okay. All right, seems we can take an early break and see you in a little bit, maybe 15 minutes. So we just talked about earlier how do you deploy and call transactions that has a smart contract, okay? So after you deploy and call, so a lot of times, oftentimes, right? I don't know about you, but for me, when I write my contract and deploy code, and it's probably not good, for production ready, right? Because, I run it locally, and then is probably not always going to work. I don't want to just deploy to the so-called mainnet. Okay, I want to have it fully tested so I have confidence. Right? Especially now, we're talking about the code that controls people's bitcoins with real money. So for testing, so we need to test it, and if the test is not good, or when we have a production issue, we want to debug it. So that's what we are going to cover here. So testing. So how many people have used JavaScript before? JavaScript, okay. So testing, I assume everybody has done some kind of testing before? Testing? Okay. No testing? Okay, you guys write code once and then it's all good? Seems like, okay. Then we don't have to cover this. Anyway, so if you are like outside of this room, I think people still, write code and still have some. Okay. And you want to rule them out before you actually do action. So that's where testing comes from. And for us, testing is also, it's like any other, because it's pretty much like JavaScript, right? So you don't have to learn new things, okay? So you can just use all other people's testing frameworks, okay? So here, I'm just using some examples, Mocha and Chai. But you can use any of your favorite. You have Jasmine, you have Jazz, you can all kind of, it's like many JavaScript testing framework out there you can use. Here is my simple example. So here, you can see it's slightly different from the deploy and call, but it also some resemblance. For example, before you do anything else, let's say you have a demo contract called demo, okay? So before you do anything else, you always compile it, okay? So basically means, this is so-called test case. So you test one way that it can go wrong and make sure it's good, right? So you just, forget. This is just the Mocha framework called describe. And then before you can think about it, it's like a setup phase, right? You set up before you run all other test cases. So you can say, oh, first, of course, I have to compile it. Like when I'm trying to deploy or call it, I always have to compile it. And then you have to get again, signer. Here, that's where the test wallets come into play. And also the dummy provider we talked about before, right? If it's dummy, what basically it does is, provider we talked about earlier, it gives access to the blockchain, right? So dummy provider, as the name suggests, it's kind of dummy, right? So it has all the interfaces you can call, but it's not actually doing anything. It's pretty much like a no-op. You call broadcast or sign, it doesn't do anything. Okay, so it's only used for local testing, which what we are doing here, right? So it's dummy. Instead of a default provider, you use a dummy provider. And then you create the signer using the test wallet. Again, you can initialize new contract instance called demo here. So demo is also very easy. You have two numbers, and then you have some methods to add them together or subtract one from the other. Okay. And then again, it's like calling. You must connect the contract instance with the signer. Okay. So once you have all of this, now you are ready to go, right? Like it's like when we are deploying it, you do all the preparation work, then you are ready to go. Okay. So what we're testing next. So for demo, as I said earlier, is actually doing. You can do two things. You can add two numbers, or you can subtract one from the other. So two numbers here, as you can see, is 1 and 2, right? Again, we have n suffix because it's a big integer. So here, we want to test it. Well, how do we make sure it's good, right? So when we add, so basically the assertion for the public method add is make sure, hey, you give me a number, and if this number is the sum of the two numbers, when I deploy the contract, it's going to be good, right? So if we run it, again, it's called add. We're still using the same syntax when we call it in the testing, because it's called add. So we can just say demo.methods.add. Okay. So we just give it the parameter. The parameter is just the sum. Okay. Okay. 1 plus 2. How much is that? Okay. Okay. Got the teacher. So for that. And okay. Yeah. It's 3. So Hopefully you can get it. And we have another options because this is the local testing, so you almost always write this line if it's local. So remember, when you call it, right, you have argument 1, 2, and then at the end, you have an option. So this option basically gives some additional information when you call it. So in our case, when you do a local testing, because you always need a transaction, but locally you don't necessarily have a transaction, right? So that's why you give it like a dummy. So basically, this is like to create an input. So you need to provide this so-called dummy UTXO. Okay, so even you don't understand, so you are almost sure when you are doing local testing, you always add this option and pass it to dummy. Okay. So here, I think, how many people have done, let's say, Ethereum testing before? Ethereum? Anybody? Solidity? Anybody? Okay, yeah. There's no shame in that. So if you've done it, it's good. It's good. I mean, we have all been there, so it's okay. I've been there, but many years ago. But anyway, if you notice the huge difference, it's a huge benefit actually. You don't run a node here, right? You don't connect to a, outside, node provider, or you don't even run like a local node here, because, as I said, in the very beginning, this is the beauty of the Bitcoin UTXO model. It's just it's a math function that returns true or false, right? Because when you are evaluating just a math function, a square root, cubic, solve some quadratic function, you don't need a blockchain for that, right? You can just run everything local. That's what's happening here. So I want you to, if you've already done some other blockchain testing, I want you to appreciate the beauty of this, because it's just a math function, right? You run the script, and you don't need network access, blockchain access, none of that. You don't need anything. You basically just run it locally, and if this is good, it's like a math function, right? If you do, let's say, square root of 4, right? Give you 2. If you do your laptop, it give you 2. Do your phone, it give you 2. The miners, right, they give you 2. The validators, right, everybody is getting the same result. It doesn't matter when, where, how you run it, right? So you just make the testing very simple. And if you make sure it's give you 2 locally, you're almost sure the miners will get the same result, right? So that means this testing is very of high fidelity. If this passes, you're almost sure the miner is also going to, the contract, when you deploy it to the actual network, is going to work, because it's like a math, right? It's pure and so-called pure, so there's no side effect, and it's so-called timeless. It doesn't matter where you run it, when you run it, it's going to give you the same result. So after you have all of this, you call it. So here, when you deploy it, when you call it, that's the end of it, right? When you call, it returns 2 things. First is the calling transaction, and also tells you the index. You now have a transaction, right? So if you remember, the input, each input is unlocking its own contract. So it also give you, hey, which the contract what I'm calling at, which input index it is, okay? So, when you are not testing, that's the end of it, right? Because you already called it, and then the transaction has been broadcasted, you are done, okay? But because since we are testing locally, so we have not, evaluate, because it's not broadcasting. So we need one more step to make sure, hey, it's doing what it's supposed to do. So you always call this function on the calling transaction using the index, okay? So what does this do? So basically, it's just locally, it runs a contract, okay? And then the last sentence, this one is, is like any testing framework. Now here we use try, so you just expect this one is good, it's true, right? So this basically returns 2 things. It's a struct, it gives you 2 things, whether this contract run is successful or not, and if it's not, it will give you an error message. So this is like a boilerplate. You almost always have to use almost the same piece of code. We are going to do the lab session this afternoon. So if you compare that code with this code, it's almost identical. I think all the preparations are similar, and then you always do this. The only difference is what kind of arguments you're passing. Okay. Testing, so far so good? Okay. All right, so we talk about, testing. As I said, this is a simple contract. That's, we call it a stateless. So there's no state. Once you call it, it's gone, right? You take so, you spend it, destroy it, now it's good. So we also, yesterday, if you still remember, we talk about another type of contract, right? You can keep going. It has memory, which we call it state, right? So what if, it's not destroyed and you have multiple transactions in a chain that keep iterating. So how do we test that? It's also similar, but there's some slight difference. And here we cover the case how you tested the so-called the counter example, right? So yesterday we have this counter example. Just a brief reminder. It's a counter example. It basically has a function and also has an internal state. So tracks how many times this public method has been called, right? We call it increment on chain. And, if we initialize the count to be 0, and then every time it's called, we're going to increment by 1. So we can know, by just looking at the latest UTXO, we can know how many times has been incremented. And that you cannot increment by 2 or decrement. You can only increment it. Okay. So that simulates the state for contract that a lot of other blockchains have. Okay. So again, it's also very similar. You do preparations, you knew, and then connect it to some kind of signer. And then here, we, instead of just doing it once, call it once, we call the method in a loop, I think 3 times, but you can do it many times. So again, that's a little bit different from what we have seen before, because now you have state, right? So you want to almost like you have a current instance. Instance, again, is the output that corresponds to the contract, the instance of the contract on chain we have showed earlier. So just very quick reminder, if you look at the instance here, right? So that's the instance, is in some transactions output. Right? This, if you want to call it, you just say dot methods and the method name, and then give it arguments, right? So this is almost like a one-to-one mapping from your local code, and then the blockchain instance out there, okay? So let's say how do we testing this stateful counter example, okay? So counter, if you still remember, we have this increment methods. Again, you can call it, and then again we get the option you can pass. So increment, the function takes no arguments, right? If you remember, so increment, you just increment. It doesn't take any arguments. So you need to give it an instance. So that's a little bit special. We have to pay attention when we're testing stateful contract. So you have to give it a bunch of options, Namely, you have to give it the next. So this next basically means you have the current instance, right? Then you update it. You get a new output. That's where the next instance is. Okay, so you have a current output. You have the new output, right? So current instance in the current output, and then the next instance is in the next output. Okay, so you're going to specify, hey, what's the new instance kept going out of it? So here, how do you get this new instance? So first, you pretty much like copy the current one. The current instance. You call dot next. It's almost like a copy. It's almost like you copy the current instance, and then you update it, right, by calling, the increment. I think yesterday, let me actually go back a little bit so you can have a sense what is, look, okay. So this is the code we used yesterday. So the counter example. So here we have a public method called increment on chain, which takes, right? And also we have another internal function called increment. Yesterday, I think Jack and some other people were asking, what do we need to, it's almost, why do we need to take the increment out as its own function, right? So here, hopefully you can get some idea. This remember this one called an increment. That one is called almost like on chain version. I call it increment on chain. So if we come here, when we are doing the testing, so once we have duplicate current instance here, we get the next instance, and then we can call the next instance dot increment. Okay, be aware, right? This thing is running on a local computer. So this, because once you separate this out, you update the state, you call this, you don't have to write another function to do the same thing, right? Because here, only one increment, but imagine it can be 100 lines. So this is the so-called off-chain code, right? Because you are testing. So you don't have to, that's a benefit. If you separate into another function, you don't have to rewrite the whole thing off-chain. You can just reuse, the code that's already in the contract, right? It can be reused at off-chain, and on-chain meaning in the contract. Off-chain means testing or deploying. Okay. So once you have the next instance, you can put it here, got next, and then dot instance, and they got the next instance. And here, this is just a different balance. For counter example, if you still remember, we make sure the balance doesn't change. So you always have the same balance. But if you have different balance, just use whatever balance you're going to have. Okay, go ahead.
Make sure you don't move the mic thing, because sometimes it's cutting out.
Oh.
Yeah, it's generally okay, but keep that in your pocket or somewhere. Yeah. When it moves around, it can cut out.
Okay. All right. Thank you. So once we have the next instance, now it's good, right? So far, so good. Next instance. I mean, whatever happens here is, again, the same with when you're testing the stateless contract. So you got the transaction back. You also have the input index. So you can say, hey, verify the contract here. Verify script is pretty much means verify the smart contract at this instance. And then you check whether it's good, right? Basically, this returns true or false, right? So if it's true, it's good. If not, it's going to fail, but give you some error message that help you diagnose it. And then the only thing, because we are doing multiple rounds, instead of just one round, we keep doing updating, right? You have current instance, and now the next instance become the current instance. So we just keep doing. I think here we just show, iteration number 3, but you can be arbitrary, right? You just keep going. So this is how you test, stateful contract versus stateful. It has some similarities, but for example, when you do the preparation and also when you actually verify it. But you also have some special difference because now instead of one instance, you're almost keeping up track of almost 2 instances, the current one and whatever the next is coming. Okay? Any questions so far? So far, so good? Okay. All right, so let's go to the next one. So as I said earlier, when you deploy your actual contract either on-chain or into your production application, usually when you want to make sure all the testing is good, right? You want to test, cover as much as possible, but almost always happens is something, non-expected. Something bad happens. For example, here, right, the test fails, right? It's return true, right? And then the problem is, what do you do? Okay, it's called so-called debugging, right? So you want to debug it. You want to see, where the bug is, and then how to get rid of it. Make sure the contract is working as expected. So all JavaScript. So console log. Everybody, I assume. Everybody. Okay. Who have not used console log? Raise your hand. Okay, so no, so that's good. So we also offer this tool called console log. The good thing is you can put it anywhere in the contract. So anything you want to print it out, you just console log and you can print out the value. Works just like JavaScript. Okay. For example, here we have this method. We're adding 2 numbers. This is actually taken from the demo contract. So we are adding 2 numbers. X0 and X1. And if something happens, if the sum is not quite working correctly, then you can print out, X0, X1, And then what if I can also print out x0 plus xy? And then you can go into digital C, trying to figure out what went wrong. Okay. So this is like almost like your first line of defense. If it's something simple, hopefully you can quickly resolve this by just output to the console and figure out what went wrong. Okay. But what if some like esoteric or non-trivial bugs? Then you need so-called debugger, right? Okay. So just again, how many people have used, let's say, JavaScript debugger from Visual Studio Code or any kind of IDE? JavaScript debugger? Anyone? Debugger? No? Any kind of debugger? What debugger you used?
Well, I used the one that was on VS Code for TypeScript.
Okay.
tsconfig, the JSON.
Nice. Anyone else use any kind of debugger? Doesn't matter. JavaScript, ID, GDB. Old one? Okay. That's good. Anybody else? Yeah, I use it a lot, but somehow you guys don't use it often. I always have difficulty finding bugs, so seems. So a debugger is a conventional tool for any kind of programs because a lot of time you just print out some messages. A lot of time it's not enough to find out where the bug is. So you have this tool called debugger. So the basic what is debugger? Debugger is almost like you put your program almost like in some kind of like almost like sandbox, and then you can tinker, you can instrument, measure, you can see where it's going, what the variables, you can stop it, you can pause it, you can have it run for a few instructions. You can almost like it's almost like putting almost like a glass box. You can see everything and you can control everything, so you can easily see to help you identify what went wrong. Okay, so one of the biggest thing is because this is just TypeScript. So you can just use a lot of IDEs already have built-in debugger. You don't have to download or configure anything. For example, here I show example Visual Studio Code, which I have all you installed. So you can set a breakpoint. Breakpoint is you just click on the left, which line of code, and when you launch your program, it's going to stop over there. It's like, usually when your program runs, right? It just runs from beginning to end. It doesn't stop. So breakpoint is a good, it's almost like a checkpoint. You can stop there, and then you can inspect the state of the program. Right? For example, here, you can see, hey, what are the variables after I hit this breakpoint? If it's 1, x is 1, y is 2 here. And then you can also look at the so-called call stack. Call stack is like function, usually A equals B, B equals C, C equals D. You can see the sequence of, calling sequence. Right? That, a lot of time you also help her to identify the problem. And also, you can even hover up. You can even tell you all if you have variables, you can just hover over it, and you just give you the, what's the value for the variable at the current state. And this is almost the best way to debug. It doesn't matter what kind of bugs you have. Once you can stop the program, and then pause it, and then see what's under the hood. Most of the time, this is going to help you to solve greatly to solve whatever bugs you are having. Okay. So here, this is a live debugging session, and also, if you're not familiar, that's a gadget over there. That's like a control panel. So you can say, hey, let's go to the next statement. Let's go to the next breakpoint. You can also step into a function, look at all the variables, and you can come out of it. Yeah, this is just like any other kind of debugger. Okay. Console log, good. That's like first line defense. This is like your final, live defense. You're almost sure you can always figure out, what went wrong using this kind of powerful tools. And here's the right. A lot of you maybe have tried some other blockchains, for example, Solidity. You don't have anything, not even close to this, because this is just TypeScript. It's many IDEs already support this. and help you. Versus Solidity, you don't have such tools. Okay, so this is another great benefit. The last benefit I want to mention before we go to another break is, package management. Okay, so I assume everybody has installed this thing yesterday, if not earlier, npm. So it's a node package management. Okay, so for Solidity, right, or for some other esoteric programming language called Move, or in some other blockchains, let's say you write a library, okay, and if you want somebody else to use it, what do you do? How do you do that? Let's say you write a Solidity, function to do square root, but then if somebody else, right, it's a library, somebody else who wants to use your tool, how do they do it? Anyone? You pretty much have to copy paste the code, right? What if the guy changed the code? They find a bug, fix it later. What do you do? You may not even know, right? It's version control, it's security, vulnerability detection. That's just like a modern programming language. Usually have a tool called a package manager. So it handles all the dependency, the version control, distribution. So you don't have to care, right? Because you always stay up to date. You just run npm install, everything up to date. You don't care, what kind of things they fix, right? So you can always pull the latest. The same here, because as I said, it's just TypeScript. So you can reuse the same npm package management. And npm already have tens of millions of libraries out there, right? You probably can use Express at the backend, some kind of MongoDB, client to connect to your database, or some kind of like a, let's say, React, or Vue, or all kinds of different frameworks. It's all pushed in the package management. So you don't have to care, right? So here's the thing, because just again, it's not a new language. It's just TypeScript, so you can reuse npm. You are already familiar with. Okay. So here I show a very simple example. You don't have to care about what exactly it's doing. Maybe later, I think a Thursday, I will cover a little bit. Basically, it's an Oracle. So if you talk about smart contract, a lot of time you heard about the concept called Oracle. Basically means you need to trust somebody, third party, to give you access data off chain. For example, weather data or flight information or price. So here you have almost like an Oracle library. So somebody else write. I mean, in this case, we wrote it, and we then publish to npm. Here, you can just go there, simply npm install. Let's say, sCrypt, Oracle. Then you can pull down this library, and then you can just import it and use it in your smart contract. For example, you say, verify test. Then you can just use the library code you just imported as if it's any other JavaScript library out there. Okay. So far so good. npm. I assume everybody is using it. Everybody's using it. Okay. So short story, you can always publish your library using npm, and then anybody else who wants to use your contract, they can just using npm install to fetch your latest contract. If you have bug fix, a different release, they can always get it. They don't need to manually copy paste. It's just not the way to manage the package these days. Okay. So I think that's pretty much what we're going to cover today. So you can deploy, you can call, and then you can test it. And then if test doesn't work out or the call doesn't work out, you can also debug it. Okay. So that's pretty much everything you need to work on at a standalone contract. Tomorrow we're going to cover, how do you do integrate your contract with some kind of apps, right? With the front end, let's say React, and then they connect to a wallet, and so you can interact with the app, with a contract. You don't have to do it using program, using code or command line. You can do it in a GUI, right? So that's pretty much I want to cover today. And then lastly, this afternoon, we're going to do that, lab again. I just want to go over quickly, so when you, after lunch break, you can come back and start working on it. So we have this tutorial called tic-tac-toe. I assume anybody has not played with tic-tac-toe? Oh, is that tic-tac-toe? Okay. So it's a popular game, and let me have a sim. Okay, somehow I can. Let me end this. Okay, so we have this tutorial, basically how do you play, how do you code a tic-tac-toe contract that's fully run on chain. Okay, this is not in a browser, not a back-end server. It's actually running on the Bitcoin network. Everything, okay. So you deploy an empty grid on top of it. Then every time you want to, if it's your turn, if Alice Bob, if Alice turn, Alice can, move, and then by signing using his Sensely wallet, okay. So here, this is just a full contract. Of course, it doesn't have a front end yet, which is what we are going to cover tomorrow. But today, it's a fully contract. You have all the props. You also have all the public methods. So it's pretty much a good summary of what we have learned so far. And the challenge, you can walk through this tutorial. You can see how this contract is written. And then we have another repo here. Basically, we create a small test for you here. You can go to this repo. So the challenge is here. We have a test written there, but then we intentionally sabotage it. So we have a few things that's missing or not quite right. So your job is to make sure the test works, that the testing passes. So if that is good, then that is a very great day for us. You can learn a lot of concepts. We have said so far how to do testing, debugging, and also you have all the syntax for what we have covered yesterday. Okay, that's pretty much what we covered today. And I think the next section, we are going to have our beloved colleagues from Bitcoin Association and ELAS to talk about what they are doing. Okay, thank you.